Alright, cool. So now that we know what amino acids look like, we can talk about how they link up and how they break apart. So the bonds between amino acids are known as peptide bonds. And imagine if we had two amino acids. So a peptide bond occurs when the carboxyl group of one amino acid joins together with the amino group of the other amino acid. And anytime a peptide bond is formed, one molecule of water is given off. So let's look at the mechanism by which this occurs. First, the lone pair of the nitrogen attacks the carboxylic acid's carbon. So remember that oxygen is extremely electronegative and draws electron density away from the carboxylic acid carbon, which makes it partially positive and susceptible to an attack. What results what results is a temporary intermediate where the oxygen is negative and the nitrogen is positive. And so when the double bond reforms, the hydroxide picks up the H from the nitrogen, neutralizing the chain and giving off a water molecule. So when this process happens over and over again, what forms as a result is called a polypeptide. And it's a polymer. Proteins are polymers. And the end chains of the polymer are known as the N terminal and the C terminal, depending on which atom you have at the end, whether it's a nitrogen or a carbon. So that's how peptide bonds are formed, but how are they broken? Well, there's a lot of different ways to break amino acids, but two I'll talk about are acid hydrolysis and proteolysis. And so, acid hydrolysis, like the name suggests, involves using some sort of protic acid, water, and heat in order to break peptide bonds. But it's non-specific, which means that it will break any peptide bond. Remember, which specifically only refers to the nitrogen bonded to the carbonyl group, but it's non-specific in the sense that it'll break a peptide bond of any amino acid. Whereas for proteolysis, it depending on the protease used, it will specifically break into different fragments. And I'm sorry, I didn't write it down, but proteolysis involves a set of enzymes known as proteases. So depending on the protease used, the fragments that result will be different. So for example, trypsin and chymotrypsin are two different proteases. One cleaves at positive amino acids and the other cleaves at aromatic rings, specifically at the C terminal end. So those are a lot more specific compared to acid hydrolysis.